Theorem 4 is the converse of this theorem. What does this theorem state? It states that chords of a circle that are equidistant from the center of a circle are equal, just the converse. Chords of a circle equidistant from the center of a circle are equal. Now, what does equidistant mean? Equidistant means at an equal distance. Let's see what it means. Say this is your center. Let's draw two chords. Let's say one chord AB, CD. So you join these, and these chords are such that its distance means perpendicular distance from this from of the center from the straight line, the perpendicular distance of this straight line. Okay, this is M and this is N. These two perpendicular distances are equal. So clearly what is given here? It is given here in the last theorem. It was given that chords are equal and the distances are equal. But here that it is given that distances are equal. That is OM is equal to ON. And our conclusion here is just the converse of the last theorem. Our conclusion here is that the chords must be equal. Chord AB must be equal to chord CD. Okay, just the converse of the last theorem. Let us look at the next theorem and the last theorem. This theorem in itself is not important, but the deductions from this theorem are very important. Okay, the theorem states that through any 3 points there can be a unique circle through them. Through any 3 points, any three non-collinear points. What do you mean by collinear? On the same straight line. Through any three non-collinear points, there can be one and only one circle. One and only one circle. Why the one and only one circle? Why this kind of language? Because the circle will be unique. Okay, only one particular circle. Okay, and no other circle can be drawn. Okay, so that is the last theorem. But here the deductions from this theorem are important. The first deductions, we also call it the corollaries. So first corollary is the first corollary of this theorem is that the perpendicular bisector of the chords of a circle always pass through its center. The perpendicular bisector of a chord of a circle must pass through its center. Okay, so what does this mean? I have a circle. We take a chord. Let's say this is the center. If I have a perpendicular bisector of this chord, then according to this theorem, it must pass through the center of the circle. Okay, let's say, so given here, straight line OM is a perpendicular bisector of the chord AB. That is what is given to you. Okay, what you can conclude is, this is given to you, and from the above theorem you can conclude that OM, not OM, let's say, let's call it something else. Let's call it straight line MD. You can conclude that MD passes through O. Okay, so you have a straight line MD, which is a perpendicular bisector of a chord. Okay, this is a perpendicular bisector. MD is a perpendicular bisector here. Fine. Now, I produce this, when I produce this, I will see that it must pass through the center of the circle. That is what it means. So any perpendicular bisector of a chord will always pass through the center, which means that if I have multiple chords, say if I have 5 chords, and if I draw perpendicular bisector of 5 chords, then what will happen? At what point will they intersect? Common sense? Can anyone tell me? Can anyone tell me? If I have 5 chords, and to all these 5 chords, each of them, I draw a perpendicular bisector. So what should will be the point of intersection? Yes, anyone? Abhishek? No one? It must pass through the center of the circle, obviously, because of this chord, if this perpendicular bisector is passing through the center, then if you have many chords, then they will meet at the they will intersect at the center. Let's see how does this come from corollary 2. The perpendicular bisectors the perpendicular bisectors of two or more non-parallel chords which are not parallel. Perpendicular bisectors of two or more non-parallel chords of a circle must intersect at the center of the circle. So what does this mean? The one that I was saying, say I take two non-parallel chords. Say I take a chord here, AB, and say I take a chord here, CD. These two chords I have taken. To each I draw a perpendicular bisector. Perpendicular bisector means this part is equal to this part. Another perpendicular bisector. These two perpendicular bisectors will intersect each other at the center of the circle. That is what it means. Any questions or given? Let's call this as M, this as D, and this is, let us call this as N, and this as L. So MD and NL are perpendicular bisectors. This is given to you, and these are perpendicular bisectors of the chords AB and CD respectively, of the chords AB and CD respectively. What can you conclude? You can conclude the point of intersection of the straight lines MD and NL MD and NL is O, the center of the circle. Okay. So point of intersection of MD and NL, these two straight lines will always be the center of the circle. And you can have any number of non-parallel chords. You can have, even if you have 5 non-parallel chords, they will all intersect at the center of the circle. Okay, so this one was the second corollary, and I think that's it. There's the third corollary, but then that is not required. Okay, so this with this we come to an end of the parts on theory part of this. Okay, now let us move on to some problems. I don't have ready notes for this chapter. Okay, so you're expected to take down notes from this only. Right now, I don't even have scanned copies of the exercise. So I'll just copy the question for today. From the next time, um, I will give you a scanned copy and I will do it from there. I won't copy the questions. Exercise 15.1. The next question, that the one question we did from exercise, this example that we did yesterday, this one. This one was from the same exercise, 15.1. This was problem number 4 from the exercise 15.1. You're going to do number 5 from the same exercise. Let's see what the question says. A chord of length 16 centimeter is at a distance of 6 centimeter from the center of the circle. From the center of the circle. Find the length of the chord of the same circle which is at a distance 8 centimeter from the center. Okay, when I say distance means perpendicular distance. A chord of length 16. Let's try to draw a diagram. Chord of length 16 centimeters. Yeah, let's take a chord. The length of this chord is 16 centimeters. Let's write it. Length of this chord is 16 centimeters. Is at a distance of 6 centimeter from the center of the circle. When I say distance of 6 centimeters, when I talk about distance of a point from a straight line, I mean the perpendicular distance. So what I do is I draw a perpendicular on this straight line. And I say that distance of the center of the circle O from the chord AB is 6 centimeter. Perpendicular distance. Question is find the length of the chord of the same circle which is at a distance of 8 centimeter from the center. Now you have to find the length of the chord of some other chord which is at a distance of 8 centimeter from the center. Let us say that, let us consider a chord CD. And let us say that this chord is at a distance of 8 centimeter from the center of the circle. You need to find out the length of the chord CD. So how will you find? Remember, in this kind of a problem, the first thing is we'll proceed to first find out the radii of the circle. Let us call this point M and let us call this point N. Okay. We'll first proceed to find out the radii of the radius of the circle, not radii, radius of the circle. Okay. So what we do here is we join these two. This form the radii of the circle. So we join these two. Also, you see that OM, it is given to you that OM perpendicular to AB. Then what can you conclude? What can you conclude? From which theorem? From the second theorem. You see that if OM is perpendicular to MB, then I can say that OM must bisect the chord of the circle. That is, AM must be equal to MB. So therefore, I conclude that AM must be equal to MB. And why would I conclude this? You'll write the statement. Any straight line through the center of a circle which is perpendicular to a chord bisects it. That was the theorem, statement of the theorem. We have written that. So OM is equal to AM is equal to MB. Let us now find out the lengths. Therefore, AM is equal to MB is equal to the entire length of the chord is 16 centimeter. So AM and MB both must be equal to half of AB, which is half of 16, which is 8 centimeter. So both AM and MB both are 8 centimeters. Let's say right is here. This is 8 and this is 8. Just for our information. Now you look at this right angle triangle here. In this right angle triangle, you have your OM given as 6 centimeter. MB we have just calculated it to be 8 centimeter. So therefore you can calculate OB because it is the hypotenuse. So let's proceed to calculate OB. In triangle OMB, OB square is equal to OM square plus MB square. And OM square is 6 square and MB square is 8 square. So which is 36 plus 100, 64, which is 100. So therefore, what is the length of OB? 10 centimeter. So you've got the radius of the circle. OB is the radius of the circle. Once we have got the radius of the circle, what we'll do now here is we'll join OD also with the help of a straight line. So if we have calculated this radius to be 10 centimeters, then this must also be 10 centimeters. So let us write it down. We'll write here that OB is equal to OD is equal to 10 centimeters, right? OB is equal to OD is equal to 10 centimeters. And what is the reason? Radii of the same circle. OB and OD both are radii. Okay. Once we have found OD, now you look at this right angle triangle here. This right angle triangle. In this right angle triangle, what all do you know? You know the hypotenuse OD, right? You know the perpendicular 8 centimeter. So you can calculate ND, right? The base. Let's proceed to calculate ND. So in triangle OND, you have OD square is equal to ON square plus ND square. ND square. Now you put the values. What values do you know? You know OD 10 centimeters, you know ON. OD, you know 10 centimeters, ON, you know 8 centimeters. You have to calculate ND. That means ND square is 10 square minus 8 square, which is 100 minus 64, which is 36. That means ND is square root of 36, which is 6 centimeter. So you have managed to calculate the length of ND. So ND, the length of ND here is 6 centimeters. Now once you know this length, ND, then can we know the entire length of this chord, CD? Yes, we can. Because,
Yes.
tell me how.
CD is equal to twice of ND.
Huh? Why?
CD is equal to twice of ND.
Why? Tell me why. Tell me the reason.
OD is the perpendicular bisector of CD.
O
That's why.
ON, not OD. Very good. ON is
Oh,
the perpendicular ON is the perpendicular to CD, not the perpendicular bisector. ON is the perpendicular to CD. Therefore, CD must be equal to twice of ND. So you'll write here, since ON is perpendicular to CD, that means CN must be equal to ND. And what is the reason here? The reason here is any straight line through the center of a circle perpendicular to a chord, which is perpendicular to a chord bisects it. Hence, hence length of the chord CD is twice of ND, which is 2 into 6. It's 12 centimeters. That's it. Any questions on this problem till now? If not, then I will stop here for today. And not only today, but uh, this hopefully, I hope that the physical classes will start after you know uh, this vacation.